All right, good evening to my Elements of Calc 2 students. I'm going to take a look at problem number 2 here, okay? So on the pretest. So this number 2. So just reading this off to us, it says, oh, an oil well produced $4 million in its first year of production. Each year thereafter, the well produced three-fourths as much income, that's why I said dollars, okay, in the previous year. Um, what is the total amount produced by the well over 8 years? Okay, so here's what we're going to do. Just going to set up a little table here first and then say, okay, in year one, what did it produce? It produced $4 million. So we have, we'll say it produced a amount of money. In year two, it produced a times three quarters. Okay. In year three, it was a times three quarters squared. Year four, it was a times three quarters cubed. Year five, AR to the fourth. Year six, AR to the five. And then year seven, it was AR to the sixth. And then what do we have here? We have AR to the 8 years. Okay, so I want year eight. It was AR to the seven. Okay, and I'm going to say that this is equal to some kind of a sum here. Okay, now the next thing I'm going to do is multiply this sum by R times whatever S is. Okay, and we're going to go through and say, okay, well, let's go ahead and do this. And what's going to happen is this first term here is going to be AR, and then we're going to have AR squared, AR to the 3, AR to the 4, AR to the 5, AR to the 6, AR to the 7, and then AR to the 8. Okay, and all I did was I said, okay, we're going to set the sum up, and I'm just going to work the problem with letters rather than numbers. Okay, that's one of those things that we get to do. And then we'll say, okay, what are we going to do now? I want S minus RS. So we're going to say S minus RS. So what we're going to do is we're going to take this top row, we're going to subtract the second row from it. So is there an A here? No, but there is an AR. So these ARs, when I subtract them, are going to go away. This AR squared is going to cancel with this AR squared, etc., until we get almost to the very end here. Okay, so we're just canceling off what we're doing here. We have S minus RS. So we're going to end up with, this was A, right? That's the first one, minus AR to the eighth. Okay, and that's what we have over here. Okay, what we're going to do here is we're going to go ahead and take an S out. That's going to be 1 minus R. This is equal to, I'm going to factor this A out of this, and this is going to be 1 minus R to the eighth, like so. Okay, and then the last thing we're going to do is divide by 1 minus R on both sides here, divide by 1 minus R. So this total sum is going to be A, remember that was 4 million, 1 minus R to the eighth, that was 3 quarters, divided by 1 minus 3 quarters. Okay, and now we'll start cleaning this up a little bit. So this is going to be 4 times 10 to the $6, okay, times 1 minus 3 quarters raised to the eighth power, okay, divided by, well, this is going to be 1 minus 3 quarters. This is just going to be 1 quarter left, right? 1 minus 3 quarters will be 1 quarter left. We'll go ahead and sort this out. This is again going to be S. So we actually going to end up with 16, right, times 1 minus 3/4 raised to the eighth power. And we're going to go ahead and get our handy dandy calculators and go ahead and sort that out. Okay, so the reason why I did the setup as slow as I did was because I never know where to stop my geometric series. Like they technically go on forever, but this one only wanted to know 8 years. And I wanted to do it the clever way. I didn't want to type out 8 years where I was doing all the numbers because that'll take a long time and it'll be kind of messy with all the numbers we have to put in the calculator to deal with it. So I did it with just letters first to get myself where the solution is going to be. Now that I've got my 16 million, Okay, and I'm going to say this is 1 minus, actually, I'm going to do it this way. I'm going to say 3 divided by 4 equals raised to the 8th power. Okay, and we're going to say 1 minus that answer. All right, and then times 16. And we're going to end up with 14 .3. There we go. 14 point. Let me see. We have 398. All right. 398 and then 193. So this is going to be $14 million, right? Because we started off with $4 million at the beginning. So we said 4 million times, right? This was $4 million. And then we just let all the numbers were after that were unitless. We don't have to worry about that. So this was the only one that had a unit, which was in dollars, millions of dollars, really. So we actually end up with 14,398,193, I guess, in 36 cents. Okay. We wanted to go that far with it. But that's how I would do this problem. I can't stop you from just calculating this out and adding up all 8 of these things. I'm just going to let you know that I know it seems like a much more concrete way to do it, and it kind of is, but there's a lot more chances where you can go kind of wrong with a mistake and some kind of computational error with that. So I wanted to do it this way because it saves me the time of doing the numbers until the very end. When I type up the numbers, it's just one kind of big calculation, but it's manageable, right? I would, if it was bigger than this, I might break it into parts, but this was a manageable calculation, and just to go with it that way. All right. So I'm going to say thank you very much for watching the video. Good luck studying, everybody. I'm sorry that the first video didn't have sound, but I think we are back fixing that problem. It's just going to take me a while to catch up with it. All right. Take care. Okay. We're going to say stop and end.